Hey guys, here we go. It is quarantine chemistry. Welcome to Monday morning. It is 5:39 a.m. I've been up since about 2. Just had a lot on my mind and a lot on my heart, and so at about 3:30 I decided to get out of bed and take a bath and watch a show on Netflix. And I thought, you know what? Let's just go ahead and get the chemistry video done for the day. So here we are, 5:30 in the morning. Okay. As always, at the beginning of my class, I open up in prayer. And I think that right now, during this very strange time, that I really wanted to say a prayer focusing on where our hearts and our minds are, not the situation as a whole really, but where our focus is. So if you all would join me in prayer this morning, then I would really love to get our lesson started off this way. Dear Heavenly Father, what an opportunity to still be able to come before you, where we're all in our different homes and locations, and we can still reach out together and join together in prayer. Lord, I want to pray for each of my students that their hearts not be troubled, that their minds not be worried and concerned. I want to pray for their parents and my own heart and mind, Lord, that you tell us that you are the author of peace, that you're the Prince of Peace, and we believe your word. Lord, I pray that you pour your peace and your renewed morning mercies out on each of us. Lord, I pray for quiet hearts in a time of disturbance. I pray that you can filter through the noise so that we can hear your voice above all. I pray that you be with each of these children that I already miss. Be with us during this section of this lesson, that we can be focused and keep our eyes stayed on what you have had us commit to do. All these things in Jesus' precious name. Amen. Okay, here we go. Module 12. We're talking about heat, energy, and temperature. Okay, you're going to notice I am in my kitchen. I don't know if y'all, let's see, I'm on my webcam. I've got everything set up in here. My husband built me this really cool island. So it's movable, so when I do like food prep and stuff, which is totally cool, that I have this place, and so that's where the webcam is videoing me from, is from my cool new island, and it rolls around. I can maneuver it all around my kitchen, so I feel like a big shot. So I'm just like super cool. So anyway, okay, let's look on page 418. My book is over here, my notes are right here, and our math problems are over here. I did send out an email the other day that I had an attachment with your test on it for this week. We're doing one whole module in this week, and I think that's important to do right now. There's a lot of uncertainty as to what's going to happen over the next few weeks as far as school goes. So I want to make sure that we get this moving, okay? So go ahead and open up your book to page 418, and we'll just kind of flow and follow through. But I did put some on your test. That's what I was saying a second ago. On your test, I did put some little helps on there on your third sheet, and those are going to be really important that you use those, okay? I also wanted to tell you that a huge part of your test is resorting all the way back to biology, meaning vocabulary. So if you see stuff that's in blue in the book, like on page 419, heat, energy, work, those are all vocabulary words. And a big chunk of your test this week is vocabulary. So start working on those, and that's really going to help you out a whole lot, okay? So, have you ever sat at a campfire and looked at the flames pulling forth? They just bellow up from the glowing embers of the wood and thought, what in the world is happening there? Well, a lot of y'all haven't ever done that. But I can tell you sometimes a fire, like a campfire or a bonfire, is just mesmerizing. Yeah, you can just sit there and look at the glow on the bottom and how the flames just pour out of the top. That's what I'm talking about. Where do the flames come from, though? Everything on the bottom is all glowy and orange and beautiful. Where do the flames come from? Well, whatever matter undergoes a chemical change, that change is accompanied by either a release or an absorption of energy. This module, we're talking about energy, heat, and temperature. So how all these things work together. Now, heat and energy. That is our first portion on page 418. We're going to start with the vocabulary in 419 of energy. Energy is the ability to do work. Well, what's work? Work is what I'm trying to get out of doing. I have found that I like this certain spot on my couch, and as long as I sit there and I keep my mouth shut, I can get out a lot of work. So, work is where force is applied to an object times the distance that the object travels parallel to that force. Well, and that's just a sweet little definition. The force applied to an object times the distance that the object travels parallel to that force. So it's really, work is mathematically force times distance. Knowing these two definitions, one, for work to occur, there must be motion. After all, and that's like I'm sitting on the couch, there's no motion. So, thus, no work. So, after all, an object must travel a distance parallel to the force that is applied. So if it's traveling, then it's in motion. If there is no work force times no distance, then there's no work being done. Let's say I don't really have, let me start with my stove. I can push all day long on my stove, but I can't make it move. I'm not strong enough. I don't have enough force to push behind it. So there's no distance. Therefore, there is no work being done. If the wall moved, that is work. So if I pushed hard enough, put enough force that I can make the wall move, then that would be work. The distance that I moved the wall with the amount of force that I put on it is the work. So now, energy is the ability to cause that motion. Energy is the ability to do the work. Now, thinking of flames again, let's go to page 419, and it tells me in my notes to read this. So everybody look at the second and third paragraph. Now that we understand the definition of what work is, we can see that the definition of energy makes a lot more sense. Energy is essentially the ability to cause motion. As mentioned earlier, that the flames in a fire are a form of energy. Based on our definition of energy, then, the flames in the fire must be able to cause motion. What motion can the flames cause? For one thing, we can see smoke rising up out of the fire. The energy in the flames caused this motion. Also, if we were to put a pot of water on those flames, it would eventually start to boil. The energy in the flames caused the motion of the bubbles that result from boiling. Finally, think about the fact that we can feel heat coming from a fire. The only way that heat can get to us is by traveling. So, the fire's very act of warming us involves motion. Now that we're on the subject of heat, let's look at the definition of heat. Heat, energy that is transferred as a consequence of temperature differences. Energy that is transferred as a consequence of temperature differences. Now, last paragraph, page 419. The one thing we can see from this definition is that heat is energy. This should make sense if you think about it. Energy is essentially the ability to create motion. If we used heat from a fire to boil water, the water would create motion. Therefore, heat must be energy. What we see from the definition is that heat is a special form of energy, energy that is on its way from a hot body to a cold body. Heat always travels from hot to cold. If there is no difference in temperature, then there is no heat. Now, the logs in the fire before the flame are just sitting there. They're just logs, but they have stored up energy inside of them. Trapped inside in the wood is potential energy that won't be released until it has caught fire. Now we come to page 420 and the first law of thermodynamics. The first law of thermodynamics is energy cannot be created or destroyed. It can only change its form. Energy cannot be created or destroyed. It can only change form. The definition, again, of energy is the ability to do work. And that ability to do work cannot be created or destroyed. It just changes form. In the logs, all of that energy is bound up in there, ready to come forth, but it has to have a little bit of work put to it. Now on page 420. Let's look at the first couple paragraphs there under the law of thermodynamics. This law tells us that God made only so much energy for the entire universe. This energy is used to do all the work that has to be done for the universe to exist. Since humans are not the same, absolutely, but the book says since humans are not as smart as God, there is no way that we can make energy and we can't destroy it. Now, wait a minute, you say, aren't we creating energy when we burn something? Before we start the fire, the wood is not hot, but afterward it is. Isn't that creating energy? No. Remember what we said earlier, the energy was already in the wood and it was stored there, unable to move to us and warm us. The act of starting the fire merely released the stored energy that was already there. Once the stored energy was released, it became heat and was able to warm us up. Now, let me look here. The two definitions are potential energy and kinetic energy. Potential is the energy that is stored. It has the potential to do something great. Kinetic, now the term kinetic means motion or movement. I know several of you, your mamas have probably told you since you've been a homeschooler that you that you might be a kinetic learner. That means a hands-on learner, that you learn through movement rather than just seeing it or hearing it. You learn through movement. And I think most of us are really kinetic learners, but kinetic energy is energy that's in the motion. Page 421, the top paragraph. In chemistry, the difference between potential energy and kinetic energy is straightforward. Heat is considered a type of kinetic energy. After all, heat is defined as energy that is being transferred as a result of temperature differences. For something to be transferred, it must move. Remember, what does trans mean? Do you remember that from Biology 2? The word or the prefix trans means across. So for it to get across, it's got to move. Just like when you go to the bank and you make a transaction, trans means across, action is the motion. So transaction is the motion of moving to an action. Pretty cool. So, since kinetic energy is energy in motion, heat is kinetic energy. On the other hand, all substances have energy stored in them, so all substance has potential energy. Remember how we talked about the table and how everything, like my countertop right here, it feels solid, but we know there's energy inside of it because there is some motion. Remember, there is motion because everything is slowly vibrating all the time. But when we add energy to it, when we add heat to it, the motion, everything gets moving faster. So then the kinetic energy is released and it starts to melt. Remember, it's all making sense now. Oh. Okay. Where was I? On the other hand, all substances have energy stored in them, so all substances have potential energy. These are not the only types of potential and kinetic energy in chemistry. However, in later modules, we'll introduce other types of potential and kinetic energy. Okay, but right now we're going to focus on these. So, turn my page. Units to measure heat and light. Now, let me find my page. Energy is measured in joules. Now, I'm going to look now to see if you can see this. If I pull this board pretty close, y'all see that? Oh, it's going to look backwards. Sorry. I wish there was another way to do it, but I can't, so we're just going to have to go with it. This is joules, Joules. Joules is a measurement. It is not like joules, rings, joules like that, Jewels, but it sounds the same. So, energy is measured in joules. If you were to lift a 102-gram object 3 meters off the floor, that actually creates 1 joule of energy. So, this, matter of fact, get in my cabinet. I've got a scale. I'm going to weigh this little thing. Got grams. This is 120 joules. Is that about right? Right. This is a medium-sized apple, and it's 120 joules. So it's 120 grams, sorry. So it's just a little over 1 joule if I take this and go down and lift it up 3 feet. The energy that it took to raise this 3 feet is equal to 1 joule of energy. That's how it's measured out. So, on occasion, you'll use energy measured in chemical calories or kcals, but we're not going to get into that much. We're going to talk about it a little bit here in a few minutes, but you just don't use it that much in this chemistry, okay? So now we're going to talk about, let's flip over. You're going to seem like you're skipping a lot here to page 427. 427 we're going to talk about the calorie unit. A calorie is the amount of heat necessary to warm 1 gram of water 1 degree Celsius. 1 calorie is equal to 4.184 joules. Now, that's why in the definition of calorie, it says the amount of heat necessary to warm up 1 gram of water 1 degree Celsius. Now, in this whole calorie unit, it talks about heat and creating heat. So when you are working out or you're running around playing and you start getting hot, your body builds up heat. And your body builds heat and starts to burn those calories. Use calories with a capital C. So it starts to use calories, and one of those calories is equal to 4.184 joules. So that's a measurement of the energy released, which we can also call a calorie. So most people are familiar with the kind of calories that you eat when you eat food. A cup of broccoli has 35 calories in it. A number one off the Chick-fil-A menu has, without a drink, 840 calories for just a chicken sandwich and fries. So an average adult burns about 2,000 calories. A kid can burn up to 6,000 calories. That's why kids that move and run and play a lot tend to be pretty slim. They typically don't have to worry about weight because they are actively burning and creating heat. They're burning off those calories. Those calories give us energy at the cellular level. And here's the difference. 1 calorie, when we talked about the chemical calorie before, and remember that a chemical calorie is also called a kcalorie. K here is kilo, so it's a kilocalorie. And what number do we associate with kilo? I wish I could write all this backwards so it would be easy for y'all to see. 1,000. 1,000 is associated with a kilo. So, taking that information, 1 calorie in foods equals 1,000 kcals, or chemical calories. If a chemical calorie can create energy to raise 1 gram of water by 1 degree Celsius, if a calorie can raise it 1 degree Celsius, then a chemical calorie will heat it up 1,000 grams of water 1 degree Celsius. So regular calorie, 1 gram, 1 degree Celsius. A kcal, or a chemical calorie, 1,000 grams by 1 centimeter. I've got that big C sitting there. Celsius. So an average human body can burn about 22,000 to 2,500 a day, not doing a lot of work. So that means that you can create enough heat in kilocalories to increase 2.5 million grams of water 1 degree Celsius. So that's a lot. It's a lot of water. But God designed us that even in all of this heat that we create, He designed a cooling system. So He designed our brain to regulate how much, what temperature that we should be at. So we can go a little high when we're working out and that, or exercising or doing heavy work. By doing that, it allows us to, it increases our body heat. But what's the one thing that happens when you do all that? You start to sweat. And that sweat with the air around you will actually cool your core. It will cool you off. And then sometimes you'll start feeling lightheaded or dizzy, and that means that you're creating too much sweat and that you're dehydrating. So you always want to drink in water. So as you're working out, as you're working, you drink in the water, it replenishes your fluid. The drinking itself helps cool your body. That's working itself in reducing the temperature so that as you sweat, everything cools off the external part of your body, which helps cool your core. Crazy. Now, measuring heat. Turn to page 429. We're going to look at our first formula here, okay? This formula is called the MCAT formula, all right? Now, to measure heat, oops, how about hit that, knock that over. I borrowed it, so I don't want to mess it up. To measure heat, we're going to use the MCAT formula here, but we need to know what all of these things stand for. So if you have to pause the video to write this stuff down, I highly recommend that you write it down. To measure heat, you use the MCAT formula. That is Q. You're looking on page 429. It gives you that. This is equation 12.1, okay? So Q equals M times C times delta T. Now, remember that I told y'all that anytime you see delta means change. So anytime you see that delta, that means change. Now, let's talk about what all those other letters stand for. Q. Q is the amount of heat absorbed or released. Now, if it's absorbed, it's going to be just a regular Q. If the heat is released, that's lost heat, lost energy, then that's going to be a negative Q. Okay? And we'll go over that a little bit here in just a few minutes. Q is the amount of heat that is absorbed or released. Positive Q is absorbed. Negative Q is released. M is the mass of the object. That's how much it weighs, and it's going to be shown in grams. So if you're given a problem that has kilograms, what are you going to do? First thing, you're going to go ahead and convert those kilograms. C is specific heat of the object. We're going to talk about what that is in just a minute. There's also on your sheets that I gave you a table of most common specific heats. So there's all of these different elements that have a specific standard, specific heat, joules over grams times degrees Celsius. So I want to make sure that you understand all of that because that is on that sheet and you're going to need it in a few minutes when we work a problem. C is specific heat of the object. Then your delta T means it's a change in temperature and the difference between an initial and a final temperature. So here's your next bit of information, your next equation. On page 429, equation 2.2, delta T, that means the change in temperature, and it equals the final temperature minus the initial temperature. Because what we're talking about is the amount of heat, the whole get up here is the amount of heat, as in Q, that is either absorbed or released. So there's going to have to be a change of temperature. The change of temperature is going to be the difference between the final and the initial temperature. Okay? It's simple math, adding, subtracting. We're going to do that in just a second. Okay. Specific heat. Make sure I have it on my page here. It's one of your definitions on page 430. And it's also the table on page 430. This is the table I was telling you about. You've got all these different substances. These are the specific heats of common substances. You will not be asked a question for the specific heat of something that is not on here. Okay? So let's look. Specific heat is the amount of heat necessary to raise the temperature of 1 gram of a substance by 1 degree Celsius. Now, we talked about that a few minutes ago. We talked about the calorie and how the calorie relates to joules, about the energy that it takes to raise that. So if we know the energy that it takes to raise that, then we're also going to know that that correlates to the amount of heat that is released. Okay? So the amount of heat that's necessary to raise the temperature of 1 gram of a substance by 1 degree Celsius. Okay. Now, we're going to look now at 12.1. I'm going to write this on the board. You may not be able to tell a whole lot about it because it's going to be backwards on your side, but I think you'll be able to get the gist, okay? If you cannot figure it out from the board, then what I want you to do is look at your example on page 431 and 432, okay? You're going to look at that anyway. Something just clicked behind me. Okay. I'll try to set this up where you can see a little bit better. Well, there it goes. I tell you what, let me move. There we go. Set that up a little bit better. Okay. 12.1. I think it's clicking behind me. I think it's my dishwasher. Turned it off because it's freaking me out. Okay. I can leave that there too. Get low. This is a mess, y'all. I need my big old thing. This thing ain't working good. Hang on. Would help if I balanced it. Okay. Now that we're back, let's look at our problem 12.1, okay? To cook an omelet. Have y'all been cooking omelets during your quarantine? I think I might make me one today. A 5 kilogram iron skillet must be heated to from room temperature to room temperature is 25 degrees Celsius average to 150 degrees Celsius. How many joules of heat must be used to accomplish this? How many joules of heat is it going to take to heat up my orange skillet? Well, I personally wouldn't put an omelet in an iron skillet because it sticks. Unless your iron skillet's really seasoned, I'd put it in an omelet pan. So, but this stupid question wants to know a stupid answer. I'm going to give it. You with me? Okay, here we go. First thing we're going to do is write our given. Y'all love when I write that given, huh? What have we got? We've got a 5.0 kilogram. I'm just going to write iron there because it's an iron skillet. It must be heated from room temperature. So I'm going to make that my initial temperature is 25 degrees Celsius. And then my temperature final is 150 degrees Celsius. How many joules? So now I'm going to go to my find. How many joules of heat must be used to accomplish this task? Well, I thought I had all my stuff written down, but apparently, I've got to look through my book here because I had it all written down and I had it actually torn out. And look at me. What a goober am I? Because I had it down the way that I wanted to write it, not the way the book was telling me. But one thing I do know is I need my handy dandy calculator. Okay. So, what's my plan? Let's make a plan. Okay, so I'm going to, the first thing I know that I want to do is I'm going to use my MCAT. So I'm going to write down Q equals M dot C dot change to T. Now, why is that called MCAT? Because the delta kind of looks like an A. MCAT, MCAT. Okay? So here we go. Another thing I'm going to have to do, this is my 12.1. Another thing I'm going to have to do is I have an initial and a final temperature. So now I'm going to have to do 12.2. 12.2 is change of temperature equals temperature. I'm going to put a temperature final. I'm going to put FIN. I'm just going to abbreviate it. Minus temperature initial. Okay? So given these two things, first thing we want to do is fill in all these little blanks. So let's start with the M. The M is going to be the mass of the object. So over here, I personally like it when you write and use the whole page, but guess what? I don't have that luxury today. So my M is going to be 5.0 kilograms. But I've already said I'm going to need it in grams. So what am I going to do? I'm going to convert. 5.0 kilograms equals 5,000 grams. Okay? Yeah, you can see that. All right. So that's my M. So I'm going to take my little red pen and I'm just going to go ahead and make my little note there of it. 5,000 grams. Okay. Next, what's my C? C is specific heat. What are we specific heating? My orange skillet. So if I look on my little table, guess what? There's iron. And you'll notice that it says 0.4521, but it doesn't stop at that number. It's specific heat, joules over grams times Celsius. So right here, my M, let's see, I'm going to go ahead and do this. This is my M. My C, I'm just making note, is 0.4521. Is that right? Yeah. Joules over grams times degrees Celsius. So I've got that. Now I need my change of temperature, and I'm going to use this formula right down here. My change of temperature is delta T equals my final temperature, 150, minus my initial temperature, 25, equals 125 degrees Celsius. That is just all the work that's ready to be done. Okay, now I'm going to erase. No, I'll just work it out in blue. Maybe we can see the difference here. Let's see. So my Q equals M 5,000 grams times 0.4521 joules grams Celsius times 125 degrees Celsius. All right, I can see that taking it off the board there a little bit. I'm going to do a scoochy. There we go. Okay, handy dandy calculator. 5,000 times 0.4521 times 125. That number is 282,562.5. That's a big old number. But let's go back and do a little bit of extra work. Let's mark out my grams. Mark out my Celsius. So that leaves us with joules. Okay, so the answer is almost there. 282,562.5 joules. But I have to have significant figures, okay? So significant figures, how many do I have here? Let's see, 2. We're starting with 2 significant figures, all right? So we're going to take this to 280,000 joules. But we can't leave it like that either. We want to do it in scientific notation. So it's going to be 2.8, because that's our first point of scientific notation. And we're going to go 1, 2, 3, 4, 5 times 10 to the 5th joules. Now, I'm going to look in my book. Did y'all see that? I'm going to wake up my whole house. I'm beginning to think I need to use a different technique. Hang on. I've got to use a different technique. Hang on. This little easel is not meant for the work that I have to do. Hang on. Okay. We're going to do some turning. Oh, I hope I don't come unplugged. That might work. I'm trying to think, because I can see this sliding. I think, oh. Ew, something gross is on this towel. Stuck together. Maybe that'll make it stick here and not move. I'm so crafty and ingenuitive. Okay, so here we go. I don't know where the crap we were. 2.8 times 10 to the 5th power joules. Okay, so we're going to go back over this very quickly. Given, we know that we have 2 different temperatures we're going to have to determine here. The number of joules. We're going to use our MCAT formula because we're looking for how much heat that, how many joules of heat we need to accomplish this task of raising the temperature. We know that because we have a beginning and an ending temperature, that's going to be our change of temperature. We have to fill in all of these little blanks, MC, change of temp, and that's what we did here. We converted the mass. We looked up on our chart iron, because this is an iron skillet, and then we wrote down the change of temperature by just subtracting using this formula. Now, once we plug those in, we have to look at it in significant figures. Why did we choose 2 significant figures? You can't take it down to 1 significant figure. So the lowest you can go is 2. And I have 25 degrees Celsius. 25 is 2 significant figures. So my answer, I'm going to use 2 significant figures. So my 282,562.5 is now going to move to 280,000. But we can't leave it there either. We also have to use scientific notation. In scientific notation, we make it to 2.8 times 10 to the 5th joules. Done. Okay, now, on your test, it's a repeat of this problem in a different form with different numbers, but this is how you do it. So practice this, okay? Second, the other part, because I promised myself that we were going to keep this lesson that I'm doing today at an hour or less. And I'm looking at the clock and it's 44 minutes and 19 seconds. I'm going to go over some more vocabulary with you, but I'm not going to do any more math with you because you're not going to need the other portion of the math for this test. And the next portion of math does not carry over to the other modules. So I'm not saying that it's not important. This week when you're doing your work, go ahead, read the material, and work through the problems that are on the examples. You have on your owns to do, so go ahead and do those too. If you get stuck on your owns, go back and look at the examples in the book because they match, okay? And you should be able to work that out. So let's go to page 433. And we'll find it on my work here. Calorimetry, page 433. So you have the specific chart, the specific heat chart on page 430, the most commonly used ones, but you'll need to remember the specific heat of water. Now, in the next math problems, they have you know the specific heat of water. The specific heat of water is 1 calorie over grams times Celsius or 4.184 joules. That's what you're going to be using most. If in your problem it gives you calories, go ahead and transfer it over to joules, okay? Because that's what they're going to be looking for. On occasion, they might say, how many calories is it going to burn? Don't worry about that. Go ahead and just convert these two. Now, I did not include these on your test because, again, you're not going to need that. It's just something to kind of keep into the back of your mind. Let's see. Let's look at some more of these definitions. As we talked about before on page 434, when energy is released, it's going to put things in a negative number because that is the amount of energy lost because it's released. Okay. Let's keep looking. There's an experiment in there that we are not going to do that experiment anyway. We wouldn't have done it in class. I'm looking through just to make sure I don't need to cover anything else here. Okay. Now what I'm going to do over the last few minutes, I'm going to pull up your test real quick, okay? Open Google Docs. Okay. You need to know the definitions of heat, kinetic energy, specific heat, the first law of thermodynamics, calorie with a big C, energy, potential energy, work. You'll also need to know, as part of your MCAT equation, this is part of your definitions, you need to know the delta T, what that means. You'll need to know what the Q is. You'll need to know the M, and you'll need to know the C. Now, I'm looking through all of that. On the following page, page 2, show all your work for the following problems. This is an exact example. Well, okay, it's not an exact example because it's not the exact same thing. This problem works the exact same way as the one that we just did on the board. So, study the one that we did on the board, do the on your own, and that should help you out quite a bit here. My hair's driving me crazy, but I can't get it cut because nothing's open. I might just cut it myself. Next time you see me, I may be shaved bald. I may be in a little hat or something to hide the mess I've made. So, number 15 on your test is this, okay? Number 16 is extra credit. Number 16 is extra credit. If you want to do it, it's worth 5 points. If you get it right, it's worth 5 points. But it's right or wrong. You either get it or you don't. So even if you get part of it right, it's still not going to be right, okay? So extra credit, 5 points. Even though it doesn't say extra credit, it is extra credit. So now I'm going to take the last few minutes. I told you that this module was going to be short. Not a whole lot of math that I was going to get into because, like I said, even though the ideas of it move to the next 2 modules, the math doesn't. So that's why I didn't dwell on that, okay? So I sent you your test. If you didn't get it, let me know and I'll resend it. Second, I don't know what, that was my iron skillet. I just put my foot in it. I don't know what the next few weeks are going to look like, but my plan is to get you through. In this course, we stop after Module 14. We do not do Module 15 or 16. Even if we were in class every single week, we would not do Module 15 and 16 because our course time, 1, doesn't allow it, and 2, it's okay that we cut those 2 modules out. Okay, so here's the deal. We're going to keep going, but I will be sending your parents the test and the test master. So they will be grading your tests. You're homeschooled. This is how it goes. I don't want you to send me 15 tests to grade at home digitally, because then I have to print them, write all the information and make notes and all of that stuff. And I'm not going to print that stuff here at my house. That's going to cost me a fortune to print your all's things. I have a standard little HP printer, so I'm just not going to do that. So how this is going to look is, at least for the next 2 weeks, today's Module 12, we did all of Module 12, okay? And when you take your test, I'm going to send your mom and dad the answers. And they, being your honest homeschool parents, are going to grade them honestly. So then, by their choice, they can either keep your grade or send me the grade. I would prefer if you send me the grade and I could log it all into iGrade, and that way at the end of the semester you can have your grades logged. I'm happy to do that. But like I said, my best guess is we will not be back at co-op on April 6th. The curve on this virus is still going up. It is still escalating. In one day in the state of Tennessee, this was between Saturday and Sunday, the curve, the number of patients that were diagnosed increased by 36% in one day. That's a lot. I've been in a hospital setting. I've seen flu. I've seen all these different viruses and all these different things, communicable diseases. And the truth is, this one's new. This one's different. And it's mutating as it goes. Now, am I afraid of that? I'm not afraid, but I am concerned. So, but with that concern comes the fact that we're 1 week out, and let's see, 23rd, we're a couple weeks from the 6th, and I just don't see that happening. So, but we're going to go ahead and continue on. I'll continue to make some videos and walk you through, but I need you to remember you are homeschooled. Your mama is your teacher. I am doing my job as best I can from this location, but this is not the optimum setting, especially when my board is backwards. There's all kinds of little things that are different and harder. So I need you to understand I'm doing my best, and I expect you to do your best. But we're going to muddle through. And the next thing I wanted to point out to you is that, like I said, your parents will be grading your work, and sending me your grades so I can add it in on iGrade. If you have any questions, text or email me. I will be happy to respond. I'm not going anywhere. I will be at home. I may be busy doing something, but I'll get back to you quickly. But we're just going to do the best we can and see where this goes. And if we come back sometime in sometime in April, that's fine. We'll do that. But if not, then we will just carry on as best we can. We'll make those decisions as we go forward. But for the next 2 weeks, we're going to continue on what we're doing. We're going to get through Module 13 in the next 2 weeks. So this week, do number 12. Next week, we'll start Module 13. I'll send you another video. Hopefully, it will not be at 5 a.m. So I will get you another video, and we'll start going through it. We're going to do the best we can, and I hope to see you all, and keep in contact with me and let me know. Like I said, I'll send you some stuff, and you can get those papers graded. And you don't have to send the papers back to me. Just send the grades. And I'm going to send information on how your parents can do that. So I love all of y'all. I miss you so bad. I can see you all in your chairs all the way around. And I'm thinking of you and praying for you and your families. So I will see you all very soon.